Let's restore them. Write them in a binary format. Decimal not easy to read. First is the IP address. Let's take the example we calculated earlier.
111.0000000.0000001.011011111.
Then I ask a question now. When my subnet mask is a range like this, how does my mask represent? Okay. 11111111111.1111111.000000000. Now it is such a form. The above is called IP address. This is called the subnet mask. We first need to write decimal to binary. Afterwards, everyone will observe and you will understand. This is how the device actually identifies. So what does the subnet mask define the network bit and host bit parameters mean? This is very simple. The first step after we convert the binary. The second step, please pay attention. When the subnet mask is 1, corresponding to the network bit. When the subnet mask is 0, corresponding to the host bit. That is to say, we define network bit parameters and host bit parameters. These are called network bits, because it corresponds to 1. The latter is called the host bit, because it corresponds to 0. So, it's actually 24-bit network bits, and is an 8-bit host bit. The subnet mask has its own standard. It is composed of 32-bit binary, left to right. It consists of consecutive 1s and consecutive 0s. Wherever 0 and 1 are connected, 1 and 0 cannot be interspersed. 0101 in the IP address can be interspersed. Subnet masks cannot be interspersed. Must be preceded by 1 and followed by 0. Must be in this form. So now we can determine a network segment. The corresponding network bits are called network segments. I will mark. This part is called the network segment. Everyone will find. When 192.168.1.111. After combining the mask of 255.255.255.0. It can define a network segment. A network segment called 192.168.1.0. That is the preceding digits. Then take it. We can set the latter host location to 0. This is a network segment, and is a mask of 24 bits. Because it's 24-bit network bits, we can write this form. Then what we say. Direct communication on the same network segment. Different network segments cannot communicate directly. It means, when you convert an IP address to binary now, as long as the preceding digits correspond to, no matter how the latter host bits change, both of them can communicate directly. That is, as long as the previous one is the same, are in the same network segment. So no matter how these host digits change, as long as the mask is 0, can communicate directly. But if for two addresses, for example, I now have a 192.168.2.1, such an address is also a 24-bit mask. That is equivalent to a 2.0 network segment. Not in the same network segment as this 1.0. That is to say, this part is actually different. So they can't communicate directly. We can communicate with the help of routing. Can't communicate directly without going through some other behavior. If the network bits are the same, it is the same network segment. If the network bits are different, it is a different network segment. If it is a different network segment, they cannot communicate directly. Let's now summarize what we just said. the address we configured on the device interface. In fact, it is ABC 3 types of addresses. Let's look at the combination of masks and addresses. Different address ranges. That is, Class A, Class B and Class C. Their network range. I've been telling everyone just now. Class A network segment is larger. The network segment of Class C is smaller. Then there are fewer addresses that can be allocated. Okay. Let's fill out a form together. We will divide the addresses into ABC 3 categories. We're going to discuss their network bits together. Host bit. Range of network segments. Number of network segments. And the number of available hosts per network segment. First, let's look at Class A addresses. Class A addresses have 8 network bits. Its host bit is 24-bit. This is a requirement for a Class A address. So you don't need to worry about these digits. The network segment range is 0 to 127. But actually available is 1 to 126. We just write 0 to 127 here. You know it. So how to calculate the number of next network segments? There are now 8 network bits in total. Then you need to see the number of network segments to calculate. Now variable number of network bits. For us now. For example, the current network bit has 8 bits. So now it's 2 to the 8th power. But since the first digit of the entire network segment is now fixed, has a fixed value, the first bit of the A-bit address is fixed to 0. So since the network bits are a total of 8 bits, first fixed, that actually, the range that can be changed is only 7 digits. So the number of network segments is variable network power. It is variable to a total of 7 powers. So now the number of network segments is 2 to the 7th power. But due to the network segment, 0 and 127 cannot be used. So the number of available network segments is only 126. How to calculate the number of available hosts for each network segment? Here's a word. Number of hosts. As the name suggests, it is the variable host bit power of 2. That is 2 to the 24th power. But please pay attention. Subtract 2 here. We have 2 rather special addresses. A network address. A broadcast address. So let's do the calculation first. -2 here. Calculate a value. Yes, 167777214. This is the number of hosts available. Let's look at Class B addresses. Network bits are 16 bits. The host bit is also 16 bits. The network segment range is 128 to 191. The number of network segments is fine. Is a variable network power of 2. A total of 16 network bits. Class B also stipulates the first 2. Then there will be 2 fixed in 16 bits. Actually, only 14 variable network bits. So the number of network segments is only 2 to the 14th power. Don't get confused here. Then the number of hosts available for each network segment is 2 to the 16th power. Because the host bit is now 16 bits. -2. Minus a broadcast and a network address. Finally, calculate the Class C address. Class C network bits are 24 bits. Host bits are 8 bits. The network segment range is 192 to 223. You need to remember this. The number of network segments is 2 to the 21st power. Network bits are now 24 bits. Class C addresses are fixed with the first 3 digits. Everything is variable. So the number of network segments is 2 to the 21st power. The number of available hosts per network segment is 2 to the 8th power -2. Then it works out to be 254. This number looks familiar. You will come into contact with it often in the future. So let's discuss a question now. The number of hosts on this network segment. Why subtract 2? Okay. It's about one of our rules. I'll give you an example of an address. 192.168.1.1. Suppose such an address. 24-bit mask. In fact, it is 3, 255 and 10. Then let's calculate. 192 is 110000000. 168 is 0.10101000. Then 0.10000000. Last is 0.00010000. This is its IP address. Subnet masks are simple. Except the last. All the rest are 1. Okay. Above is the IP. Below is the mask. Now the mask is 0. The corresponding part is the host bit. When I put the host bits corresponding to these bits, when all are set to 0, it represents a network address of this network segment. These are the network bits. These are all immutable values. Then put the latter. All take the value 0. When I mask these host bits to 0, when all values are 0, this represents the network address of a network segment. Notice. Also called network number. It has a role. It can represent all addresses in this network segment. You will be in the routing table. See this address format. That is to say, it will appear in the routing table as a representation. There is no way to configure. For example, this is a network address. 192.168.1.0. Then copy it. See this section marked in yellow. That is, set all host bits to 1. The above is all set to 0. The following is all set to 1. At this point the number here should be 192.168.1.255. Look now. It and the above number. It seems that there is a difference. Because the last 8 bits are all 1. So this is 1.255. Such an address is called a broadcast address. Then, for a network segment, we will send broadcast messages later. In the future, your destination address is a broadcast address. Such an address is used within this network. That is, on a network segment, one address for all hosts to communicate with. If the destination address is such an address, it represents a broadcast message. It cannot be said that it is the destination address of this broadcast. So, in each network segment, these two addresses are quite special. They are not allowed to be configured on the device interface. When the host bits are all 0, this happens to be the smallest address on a network segment. When the host bits are all 1, this happens to be the largest address in the entire network segment. Minimum and maximum addresses in each network segment cannot be configured on the interface. Now let's summarize this table. Everyone can observe. For ABC3 addresses, they have a mutual law. As an address, this is the least. Only 126 available. Suppose 126. High number of available hosts per network segment. Because of the lack of network bits. Large host. We said before, hosts on the same network segment can communicate directly. So you will find more than 16 million hosts can be added to a network segment. Can communicate directly. One network segment has so many hosts that can be configured. Class B is relatively average. Let's look at Class C. The network segment can be divided into many. However, the number of host bits per network segment is relatively small. So we can draw a rule from this. For equipment. Fewer network bits. The smaller the number of network segments that can be allocated in a network segment. Because the network bits are only 8 bits. But now only 100 plus can be allocated. The corresponding number of host bits can be more. The number of available network segments within a network segment is less. The more hosts, the more. The corresponding addresses allocated in the host can be more. So you will find it's a peer-to-peer relationship. The number of Class A address network segments is small. But the number of hosts in a network segment is large. A large number of Class C address network segments. But the number of hosts will be relatively less. So it is for different companies. That is, I said before, small businesses don't have that many people. So the general Class C address is done. There are only a few dozen devices. You don't need to spend such a large network segment for it. For medium-sized companies, generally a Class B address is sufficient. But sometimes Class A is also used. Because if it is used as a private network address, divide by oneself, it's just a management issue. Also I said, the network address appears in the routing table. I will give you a simple example. For example, 192.168.1.1. You see it's only fixed up to here. That is, it belongs to the 0.0 segment. Then the configurable is from 0.1 to 0.254. In theory. For example, I am now drawing a device. Router. We haven't learned yet. Just tell everyone. Many interfaces connect different places. A data comes in from this interface. Suppose you want to go to 192.168.1.2. I'll go after that. 3. Go 0.4. Go 0.5. All the way up to 0.254. There will be a table in the router called the routing table. That is to say, a data comes in. I need to look up the table to forward. This is the interface 1 of my device. If the data comes from 0.3, forwarded from interface 1. So 0.3 corresponds to the interface 1 of the device. In the future, everyone will learn about routers. Each interface is actually a broadcast domain. Can be understood in a narrow sense as it's on a network segment. If the data goes to 0.4, I also send from port 1. Data goes 0.5. I also send from port 1. These messages are stored in the routing table of the router. Then, for the same, you may find it a little cumbersome. As a network segment, let's say now from 0.1 to 250. Leave a few. Because the interface still has an address. Let's say all these 200 plus addresses. All sent from port 1. Is it necessary to write more than 200 addresses in the routing table? Write more than 200 correspondences. This address is the same interface. That address is the same interface. Actually, 192.168.1.0. The entire network segment is outgoing from interface 1. So the routing table is written slightly smaller. Write 192.168.1.0. Such a network segment. Just go out from port 1. As 4.3. 0.4. 0.5. No need to write. Because as long as it matches it belongs to this network segment. Sent directly from port 1. You can take the overall appearance. Become smaller. This is what it means for network addresses. It can replace a whole set of addresses with a single address. Used to save routing table size. A company's internal network. Just these devices. Dozens or hundreds. Routing table is too big. 4 operators. Where does the data go? It can reach Billions of addresses around the world. Does the operator have to go to a separate deposit? Does each routing table have billions of routes? This is of course impossible. So, we must optimize it. So we usually take the network segment instead of an exact IP address. Talk here. The classification of IP addresses is finished. Next, we're about to think about a new question. We can see, for Class A addresses, it now has fewer network segments. But there are many hosts available. That means that a Class A address is good. Suppose IANA is an organization. Really assigns a Class A address to our country. For example, gives 1.0.0.08. 16 million plus addresses. That sounds great. So many addresses. If this address is really divided, that's every device in our country is configured. From 1.0.0.1 to 1.255.255.254. This is the range of addresses that can be used. If I make a division, the entire range can be paired. If both match, then, by default, according to the principle, logically it works, because it complies with communication standards. But if you say that one address is connected, does our business allow it? Over 16 million addresses in total. For our whole country. Is the business allowed? For example, some government agencies, or some banks, some securities companies. This more sensitive unit also includes some companies in a competitive relationship. Everyone is on the same network segment, can access each other anytime, anywhere. We don't have any control. Nationwide. Do you think this is appropriate? Okay. This is inappropriate. It's very unsafe. First of all, the privacy of the address is not guaranteed, because everyone is on the same network segment. So, when we use addresses, only use the specified Class A, Class B, Class C. They have corresponding disadvantages. That is, when we are assigning addresses, it will be more difficult. And we have to think about a problem. If now, when the entire country is an address segment, don't be afraid of not being enough. May also be multiple address segments. But each is such a large address segment. You will find, if someone in this address segment sends a data, I need to find a person in the whole network segment. It's very difficult. For example, there are now more than 1,600 people. Assume one device per person. In this address segment, I'm going to find one of these people now. It's too big. So very difficult. And everyone should know. We will learn a message in the future. Is a broadcast packet, called ARP. Such an address resolution protocol. Then when it does the request, it sends a broadcast packet. Based on the current Ethernet networking, we have to use ARP protocol to request the peer MAC and complete the packaging. That is, this broadcast packet must be sent by each device. That's embarrassing. More than 16 million devices now. In a broadcast domain. That is, in a network segment. You send a broadcast packet. More than 16 million people will receive. We are all obligated to receive and process. Because this is a broadcast packet. I turn on the device and it doesn't do anything. So many messages were sent out. And for the device. Every device has communication needs. Outgoing packets as long as there is a communication requirement. I just turn on the device every day. We'll receive hundreds of thousands of packages. It's too exaggerated. Each device sends a broadcast message. Then deal with. The device freezes when turned on. Because I can't handle it. So you will find broadcast message delivery range is too large. It spreads across more than 16 million devices. Once a device sends a broadcast packet, except this one, all others, tens of millions of devices will receive. This is really exaggerated. So we have to think how to solve this problem. Class A address segment is good. Lots of hosts. But use it in network deployment. Obviously it doesn't fit. So all devices are in one network segment. Obviously doesn't work. Then we have to figure it out now. Divide the whole network. It means put a large address range. Divide into multiple small address ranges. Okay. So let's go back to what we just said. Devices on the same network segment can communicate directly. Data from different network segments cannot communicate directly across network segments. It must require other means. Because we send a broadcast packet. Cannot cross network segments. So how do we go about solving this problem? How to divide such a broadcast domain into smaller ones. How to segment network segments. Able to make some broadcast packets. Pass in some cases. This is what we have to think about. Then we need to use a new technology. Subnetting technology. Called VLSM. As the name suggests. The subnet mask can be changed. The way to change is borrow from the network bit to the host bit. Let's take a look at how to borrow. Now the network comes first. Borrow from host. Is the host behind? Borrowing from it means move the network bit back a bit. Move the host back a bit. That's what I mean. This is achieved by controlling the number of network bits. Network bits can be increased. Host bits can be reduced. So this technique is called subnetting. Then once the network bit increases, it means that there are more network segments now. Relatively speaking. Although the number of hosts on the network segment is small. But also in line with our deployment logic. Because in general, in a network segment, there will not be many or even tens of thousands of hosts. This is the case. But it is rare. Because that kind of usually does other strategies alone. After borrowing from a big net, the network can be divided into several small networks. We call this kind of network a small network. Or subnet. Means small. Divide some from the original. So what can be done with such technology? Move back one bit. Equivalent to a more variable range. For example, originally for our current equipment. Now the network is here. If the network bit is moved one bit back, equivalent to the variable case multiplied by 2. Because I could only control this one. The latter one has no control. Once now this bit becomes the network bit again. There is a value of 1. There is a value of 0. Then do a combination with all the previous ones. Equivalent to all network segments multiplied by 2. Just one more. I can put some extra network segments. Redistribute to different users to use. This is the mask to increase. So how exactly does the network bit increase? It is based on the current subnet mask change. Subnet mask change. The network bit and host bit can be changed accordingly. For example, let's write a new URL. 193.1.1.0. This is a 24-bit mask. Let's calculate together. Now this is a network segment. First convert it to binary. The first 2 digits of 192 are definitely values. 11000001. Next is 0.00000001. Then 0.00000001. Finally 0.00000000. This is a network address. We also write down its broadcast address by the way. I wrote a network segment. The broadcast address is all 110000001. 0.000000001. 0.000000001. 0.1111111. This is the broadcast address. We also write down the mask. The mask must be 24 bits. So we just write 1111111. 0.1111111. 0.1111111. 0.000000000. Okay. This is the subnet mask. Let's summarize now. The network address is 193.1.1.0. The broadcast address is 193.1.1.255. Its available address range is from 193.1.1.1 to 193.1.1.254. The number of hosts is a variable host power of 2. Host bit is 8 bits. Then just subtract 2. Equal to 254. This is a standard class C address. We're going to let it go back and borrow 1 now. If after borrowing 1, the number of network segments will vary. The mask is going to be 1 here. 1111111. 0.1111111. 0.1111111. 0.100000000. So for now, you will find this part becomes the subnet mask. That means that now the variable places actually become more. That is, once this one is determined. In fact, it can be divided. A value for this bit. First I can set the above bit to 0. It's a change. Then I turn the above bit into 1. It is also a change. That is, these previous parts are actually the original. It is equivalent to 1 more now. Originally this one was out of control. Because this one only all zeros and all 1s. But now, since this bit becomes a network bit, then there are 2 values of 0 and 1. The above is the value of 0. The following is a value of 1. Then the value of 0 among these. The last 7 zeros are the network address. The last 7 ones are the broadcast address. Then taking 1 is the same. Then let's see. Does it make a difference now? For the above, we do the same calculation. The above network address is still 0. 193.1.1.0. But the broadcast address becomes 127. 193.1.1.127. The same below. The following network address first becomes 1. So it is 193.1.1.128. The broadcast address is 193.1.1.255. Then everyone will find now the network addresses of both of them. It's different. The mask is shifted 1 bit back. As a result, there are now 2 network addresses. The network address is actually the network number. The same network address is called the same network segment. Different network segments. They are no longer the same network segment. But originally they were all in such a network segment. Just because the network bits are shifted backwards. After shifting, due to the extra network bits, there are 2 more changes in the shift. Divided into 2 network segments. Only in 1 network segment. The number of hosts available will definitely change. Let's do the math. 193.1.1.1. This is unchanged. Its maximum value is 2 to the 7th power minus 2. Equal to 126. For 193. What is the available address range now? The broadcast address I have calculated is 127. Okay. 126 here too. We're actually done with the first one now. Now look at the second one. The number of second hosts must be the same. Because the two network segments must be equal. So they have the same number of hosts. The difference is this place. 128 and 255. Then it must be 128 plus 1. 129. Here is 255 minus 1. 254. This is where it is now. This is equivalent to taking a large network, divided into two small subnets. Now the two subnets cannot communicate with each other. For broadcast messages, they can't be delivered. Or, they cannot be resolved by another subnet. So now it is equivalent to, the network bit is shifted 1 bit backward. Subnet mask changed from 24 bits to 25 bits. As a result, the network bit is now increased by 1. And the network segment is increased. The range that the network segment can change has increased. But you will find less host. Originally, there are 254 host bits available for a network segment. Now it has become 126. And there is one more problem. Everyone must be clear. Originally there were 254 addresses available. But since two network segments are now divided, they add up to 252. 2 less. Because there is one more broadcast address and network address. So, when everyone learns IPv6 in the future, you will know IPv4 can save addresses. Because we divided the network segment into smaller. Therefore, a network segment can accommodate fewer addresses. Relatively economical. But every time the subnet is divided, 2 addresses are wasted in each subnet. A network address. A broadcast address. So saving or not saving? Actually it's relative. Everyone can understand. If you are interested, you can try it yourself after class. Okay. Actually, this is a fundamental mechanism of VLSM. I'll take you all to do a question. Let's feel it. Then the remaining half will be your homework. If you are interested, you can try it yourself. Just a little thought for you. Let's talk about it together. VLSM, actually, is a borrow from the network bit to the host bit. That through this form of borrowing, able to reduce host bits. Network bit increase. Added after. There will be more subnets. Network segments will become more. Each subnet is not within a network segment. Can be used for different network planning. This works to save an IP address. Maybe some students still don't understand saving. I'll give you an example. Here is a classful IP address. Classful IP means it belongs to class ABC address. When we are in contact with classful IP and classless IP, we'll refer to an agreement called RIP. While we are making some announcements, it's a class announcement. It must be based on the ABC class. The format of the mask they specify. Like 8-bit, 16-bit, 24-bit. Such a format. You will find. If I now divide a network segment, there are 30 hosts in a network segment. But if you divide it according to ABC 3 categories. Class A. Class B. Not to mention. Let's just say Class C. A network segment of Class C can have 254 addresses available. This is the smallest category. Because Class D and Class E cannot be used. The smallest that can be used. It is the Class C address with the fewest host bits. There are 254 addresses in Class C. Without subnetting, These 30 hosts want to be divided into a network segment. I hope the 3 network segments do not affect each other. Then at least give it. Allocate a Class C address segment. Then give it 254 addresses. But it doesn't have that many hosts in it. It is equivalent to wasting 224 addresses. Even if you skip the configuration, will also be wasted. Look at this segment. You can only assign 2.0 to it, because you want it not to be with 1.0. Also give it the address of 254. There are 10 people in this department. 10 hosts. But you also have to give it a separate Class C address segment. Also give it 254 addresses. That address is wasted. For a large enterprise. Very many departments. There are many network segments that need to be divided. For different businesses and different types. The address segment is not enough. It's such a waste. Each address segment. The smallest is more than 200. But not every department has so many people. So there is no need. So we're going to do something now. IP address can be made more regular. And as long as it's enough. No need for such a huge address segment. Networking based on current Class C addresses. At most 254 available. If it exceeds this amount, it will not work. If there are more hosts, then consider using a Class B address. Let's take a look at a topic. For example, at this time in this network, I got an admin address. That is, an address segment is given. Address range. Let's say 194.2.3.0. Such a network segment. 24-bit mask. Now it's time to assign it to 4 departments. These 4 departments are different departments. Then I want them to belong to different address segments. Now we have to do an address division. Assigned to 4 different departments. The first is the project department. Suppose there are 58 people in the project department. So for these 58 people, we're going to assign it an address accordingly. The next one is the RAN-D department. More people in RAN-D department. 100 people. The address is something we'll fill in a moment. Next is the marketing department. The marketing department assumes 27 people. There's something called a gateway involved. Since we haven't gotten there yet. So when I talk today, I won't count this address. But I have to design the question. I'm going to design it. Okay. Suppose there are 15 people in the finance department. We're going to make a division. As a web worker. Now you have to plan an address segment. First, I'll teach you what to do when you're doing something like this. In fact, in the future when really planning the project, by default some subnet masks are used. Mask calculator can calculate. But let's follow normal way of planning. When you do address planning, planning must be made for the department with the largest number of people. That is, find a maximum value. It must be ensured that a subnet is now sought first. Is now a Class C address segment. Make sure to ask for a subnet first. And this subnet is okay. Satisfy the situation. With the largest number of addresses. Now there are 100 people in the RAN-D department. Therefore, it must be allocated to the RAN-D department first. Otherwise, after planning the address, divide it into different small subnets. Eventually you will find 100 people in the RAN-D department can't fit in. This will not work. It's like you are cooking for others in the cafeteria. If you want to make sure everyone is fed, then you should let the big eaters come first. Small eaters in the back. It has some headroom. If you let the big eaters come later, that might be their turn. Leftovers are not enough. So, this address segment itself must be planned. Just put. Sure is reasonable. Must be allocated. But if these departments with a small number of people are allocated first, it is very easy to cause too much stuff allocated to them. Make sure. Assign to the person with the most number first. Satisfy the situation with the largest number of addresses, or the most seen. Once the address is assigned, can no longer be used by others. Notice. Can no longer be used by others. A network segment. If I assign it to the RAND department, I can no longer use it for other people, because we have to isolate different network segments. Like you cut a cake. After you cut it, give it to someone else. You can't say, others seem to have some left over. I have to come back and share it with another person. This is not possible. That's for us on the project. That doesn't meet the current overall requirements. Cannot be in a network segment. If there are a few addresses left in the network segment, I can still use it for you. It doesn't make sense to divide the network segment. So once the address is assigned, can no longer be used by others. So let's solve this problem now. We now need to know what the addressable addresses are. Distribution has not started yet. Then the address that can be allocated must be the most. Is 194.2.3.0. 24-bit mask. We first give the RAND department, because there are too many people in the RAND department. RAND department is 100 people. If a department has 100 people, then the default subnet to satisfy 100 people. So how can you be satisfied? This requires more addresses. Need more than or equal to 100 addresses. Can you understand? Since now every variable bit are 2 cases, then it is 2 to the power of x. Please pay attention. 2x squares are fine by themselves, but you have to consider. Now it's time to calculate. Each network segment has 2 addresses. Network address and broadcast address. So it is equivalent to need. Subtract these 2 addresses. X stands for variable. That is to calculate. How many host bits are there now? How many network bits? But after subtracting these 2 addresses, must be greater than or equal to 100. I want to emphasize to you. We'll learn something later. Gateway. By default, when we go to assign addresses to enterprises, you have to take into account the problem of assigning a gateway to each network segment. Since we haven't learned about cross-segment, there is no problem with subtracting 2. After subtracting 2, the address is now available, but only to ensure that the internet can communicate with each other. In the future, once we are going to access the extranet, or access across network segments, must have a gateway address. As for the gateway, we haven't talked yet. So even if it is -2, even if you subtract 3 here, plus the gateway can also be used together. I'm just giving you an introduction. Okay. Let's start by subtracting 2. This x is what we call the host bit. 100 people are 100 hosts. That x is actually the host bit. So let's calculate what x is. Logically speaking, before subnetting now, the host bits are 8 bits in total. Address that can be assigned at this time is such an address. Okay. Is 7. But everyone will find, if it is 2 to the 7th power, it's more than 100. The rest of the address is wasted. Please pay attention. We use this method when calculating. Often it is not possible to do a tight fit Not exactly calculated. So, it is normal for us to set aside multiple addresses. So now 7 host bits are actually used. That means network bits need to be borrowed. It turns out that the network bits are 24 bits. Borrow 1 now. At this time. Since I've borrowed. Subnetting for sure. Divide into 2 subnets. I'll just tell you one of the above. The first one is 194.2.3.0. Don't look before. Just look at the one behind. Originally this bit was 0. Now divide 1 more. Then this one is 1. This is the one who borrowed. Then for the subnet. Except for the one you borrowed. The last 7 bits are the host bits. All set to 0. This is what is calculated now. The above calculation should be 0.0. This one below is 0.128. That is 194.2.3.0. Mask is 25 bits. We're taking a borrow now. After borrowing. Actually, there have been 2 changes in this one. We will put such an address segment. For RAN D department. I'll mark it for you. Okay. This is the subnetting we do. Equivalent to divided 2 subnets. Next we're going to start assigning. I plan to assign to the RAN D department. Above this 194.2.3.0. And is a 25-bit mask. Let's calculate the network address. Of this network segment. 194.2.3.0. This is its web address. 25-bit mask. Its broadcast address. That is. All the following bits are set to 1. 255 minus 128. Is 127. Change this 0 to 127. Okay. That is to say. We now put such a network segment. Assigned to RAN D department. So. We can fill this network segment. To the RAN D department. Then let's look down. When I now divide this network segment to it. In fact. This network segment is given to it. So what is the address that can be allocated at this time? I just created 2 subnets. Then I used one of them for the RAN D department. Then now. What are the addresses? That can be assigned to other departments. Okay. There's only one address left. Because of the 0.025-bit mask. Already used by others. Can now be assigned to other departments. That's all that's left. In the future. When we calculate. If you do subnetting again. You can only move back from its foundation. Okay. The first part is actually the same. You can follow my logic after class. Then do the math yourself. First to the project department. To the marketing department. To the finance department. You look at the process between them. At last. We can definitely figure it out. That is to say. What we're talking about as a whole. Variable length subnet mask. Let me stress again. According to us. ABC classes are called classed. Such a mask has the form. 8 bits respectively. 16-bit. 24-bit mask. If according to such a mask. Class C must have only 8 host bits. Then the default. Is 254 addresses per network segment. You will find. These departments add up to. 254 addresses are enough. 200 people in total. That explains. If there is a Class C address. 200 people are enough. But now if you don't do subnetting. That's not enough. Because I want them to be. On different network segments. But if you don't subnet. That by default. These 254 addresses. Must be in one network segment. So now there is only one network segment. 254 addresses. 24-bit mask. There is really only one large network segment. It's called the 194.2.3.0 network segment. That is to say, the first three are fixed. This is the network bit. 254 addresses in one network segment. For R&D department use only. Or only available to the marketing department. Other segments have no address. You want the address to be enough. Also wish they were in one segment. No subnetting yet. This is impossible. That's what we mean by subnetting. Now also in a large address segment. But due to subnetting, we can do it both to accommodate all people. It can also be done that they are in different address segments. That's the point of subnetting. We subnet. Not just for calculations. You need to know this scene. Okay. Finally, let's briefly talk about classless interdomain routing. There will be a new format here. Classless interdomain routing. VLSM we talk about. It is the network borrowing from the host bit. We can put a network segment into multiple different subnets. For a large community. Make some logical divisions. Each subnet corresponds to an address range. Eventually these addresses will be applied to the network. Means this. Now, everyone can see. It summarizes the network segments on the right. Did you discover it? Classless interdomain routing and VLAM is an opposite technique. The network segment itself is a 24-bit mask. It is changed or notified. Finally made a summary. Aggregated into 22 bits. Classless interdomain routing is called CIDR. It has an alias called SuperNet. What exactly does it mean? I'll draw a picture to explain. We now do a subnetting. Look, here is a device. In this device, I now segment the network. Two different subnets. For example, it's two divisions of a company. Left is 192.168.1.0 25-bit mask. Right is 192.168.1.128 25-bit mask. Actually, it was originally the biggest word. Should be 192.168.1.0 24-bit mask. I have now subnet. I'll test everyone first. If a data comes now. This data is 192.168.1.100. Then please. Is this data sent to the left or to the right? This is a very basic question. Okay. Hair to the left. It's covered by this address on the left. When data is forwarded, it must be according to different subnets. To forwarding address. Because it belongs to the left. So it must be a left turn. But you will find. For this picture. Now it's just a borrowed one. Borrow a bit to divide two subnets. Borrow another. Divide two subnets. If you borrow 6. That is. The mask becomes 30 digits. Actually, I divided 2 to the 6th power of subnets. 64 subnets. We are exaggerating. I divided 64 subnets. It is equivalent to the original network segment. Can be divided into many network segments. Each network segment contains a different address range. If there is a data in the future, also into this device. Data forwarding. But we have divided so many network segments here. Of course, the interface of the device is not enough. So I'm just an exaggerated rhetoric. We have divided so many network segments. If there are too many network segments, I want to forward data. More information to unlock. More entries on the device. To match the data. Because there are too many network segments. Different network segments are different routing entries. To match. Then you will find more matches. This is equivalent to originally. I was going into a neighborhood to find someone. This area is divided into two parts. I can find someone directly from this area. Either go left. Either go right. Divided into A-B buildings. Later. The district was divided into 64 districts. Then I'm looking for someone. I also need to confirm one by one. But if everyone sees, will be slower. I might as well decide whether to go left or right. After entering a more accurate tour. It's just like you want to go from area A to area B. Actually, you can fly. You can also take a car. Usually, a general route is determined first. Then step by step. In fact, relatively speaking, this will transfer data faster. So we can now let go of the perspective. Don't think of it as a community. You imagine the world. A network of all things. We have now subnet. That in the large network environment. Of the entire network. You think about it. What will data forwarding look like? It will be slower. That is. Now there are more subnets. It's true that you can save IP addresses. But brought a new problem. That is. The efficiency of forwarding will be reduced. So we're thinking. When this data is forwarded. Can I see a little less information? Can you forward it a little faster? Let's look at this picture. As a company. I will give you a brief introduction. It says LAN. It stands for Local Area Network. This is an internet. That is. Between us. To advertise some routes. Check back later. To forward the corresponding data. Let's ignore its specific address format. Why do devices and operators advertise routes to each other? These you will learn when you come to the NP stage. Let's just talk about technology for now. Stop talking about the scene. Because now, in terms of some technologies of IP addresses, now a network is divided internally. 1.0, 2.0, 3.0. We can make a division. So how exactly do you calculate this? Let me tell you briefly. As the internet, there will be a lot of users connecting with it. For example, this is your company. You have to make some announcements. With the operator. That is. Devices you want to connect with them on the internet. Make some announcements. Your company notice 4. Another company announcement 4. Suppose there are 20,000 companies in region A. That's 80,000. Although the final announcement is not a single device. But it is also a large network of operators as a whole. Too much information on the internet. As for the operator. To forward the corresponding data to you. I don't care how to get to this device. Either to 0.0. To 1.0. Or to 2.0. Or 3.0. Actually. Go through this router. So I don't care at all. Whether it will reach the device precisely. As long as it is guaranteed. Now traffic can go to this exit. That's it. As for the fine division at the back. Just forward it. It's like a school. In that school. This internet assumes the principal. If this is the head teacher. Behind this is a student one by one. For the principal. It doesn't really need to know. Where the students are seated. Just need to know. Which class are they from? Just ask the head teacher. Then let the head teacher find the students. The principal has to deal with a lot of things every day. There is no need to record in which classroom and where in the school each student sits. The principal only needs to know which class the student is in. Find this head teacher. The head teacher can find students for the principal. That's what I mean. For operators, it is connected with a lot of users. So, each user will have information to interact with. Then finally, operators don't need to know everyone's precise information. Just make sure that the business can be normal, covering the current range. When the operator announces to the outside world, "We are nothing but hope," the operator's traffic can return to the internal network. So just make sure can interface with this export device. Traffic will be able to come down through this device in the future. We can now put multiple small subnets. Use a larger network scope to generalize. Then optimize the overall appearance. That's what I mean. So for the device, as long as future traffic can match such a route, be able to direct traffic to such an outlet device, it can perform more precise forwarding. This is what we call CIDR. So how exactly is it calculated? I can also briefly tell you. I'll tell you how. You can do the calculations by yourself after class. It is calculated in the same way as VLSM. First convert it to a binary. After turning, you will find they have a very large number of digits in front of them, all the same. This is a total of 4 groups. You do the math after class. The preceding digits are almost always the same. When you compare them, continue to compare until a certain person is different. Stop from that one. Then set all the following values to 0. Then it is calculated that this. The first step is to convert all the network to binary. Then start from the first. Compare later, until the comparison to a certain behind is different. The previous requirements are exactly the same. Stop all from this one. Then all the following values are 0. Then the front is the network bit. Behind the host, it is the large network segment advertised. This is what we call classless interdomain routing. Sometimes it will have some other situation. I leave you with an extended knowledge. But it doesn't matter. For example, now add a network segment 10.24.4.0 24-bit mask. So you will find, when summing up 5 of them at the same time, some problems will arise. You will find that a large network segment is counted. But this network segment will cover more. For example, it will cover 5.0, 6.0 and 7.0. Sometimes advertised routes. It's not so rigorous. 22-bit mask. Just enough to cover all the changes. It just represents from 0.0 to 3.0. Such 4 network segment ranges. But if you add a network segment, such as 4.0, aggregate them together. In the aggregated network segment, there will be several other network segments. It's just a few more small network segments. What if this happens? If this is what I said, just sum up the 4 of them individually. Then put this extra. Just announce it separately. There is no need to bring them all together. Finally, to sum up, we learned about IP addresses today. Then learn the last 2 techniques, VLAM and CIDR. We learn VLSM to make the mask longer. Learning CIDR is to make the mask shorter. I'm going to subnet. I'm going to merge these subnets again. And then announce. You might think it's contradictory. First, these 2 technologies, their scenes are different. Is not conflicting. We can take a company as an example. We as a network engineer. To plan the network segment reasonably for the company. Equivalent to. You want to assign different network segments to different departments of the company. We won't talk about switching technology today. In terms of simply dividing the network. Segment network. Then VLSM is used for network segmentation. Is used to divide subnets. Isolate traffic on different network segments. CIDR ends up just working on routers. To reduce the number of appearances. In the routing table. Optimized data forwarding. So. They are actually different. VLSM is more of a role within the enterprise. Used to divide the network. Isolate traffic from different departments. When finalizing. To inform the outside world. That's for outside announcements. Just to let the many network segment information inside. Tell others in a more streamlined way. I still take the class as an example. A class is divided into many groups. This is a class. Between different groups. To do some different tasks. Each group has a leader. Team leader is responsible for receiving and sending homework. Each group operates individually. Facilitates better management within the entire class. Equivalent to different departments in an enterprise. For the department. Segment it. Like dividing groups within a class. But this is only a means within the enterprise. If you want to advertise routes to the outside world. As a principal. Deal with so many things. Throughout the school every day. So how to divide the network segment. Within the class. The principal doesn't care. It is not necessary for the principal to know the internal structure of the class. CIDR is used here. When announcing to the outside world. Announce the most general information at present. If the data traffic goes to the operator. Then go to the specific corresponding. To the following. Which network segment did it go to? Its scope is different. One is internal digestion. Own data distribution. One is when announcing to the outside world. Announce a condensed message. Then both. One is to act internally. One is external. VLSM is for IP address savings. And achieve the purpose of dividing a network segment. So for CIDR. It is to optimize the number of appearances. Reduced announcement items. In fact. The two are combined. So it's for us network engineers. It can be understood as a test. If you are a very good engineer. Future. Actually you will see. A lot of very clean planning on the project. Is the overall network planning. Very neat. For example. You do some configuration. Make a cut. We'll leave some waste configuration. You do some transition configuration. I'll delete it for others when I'm done. To us. When planning a network. Based on the original large network. Yes. It can be designed in advance. Announce this big network to the outside world. Later. When the network segment is divided. It is just divided into a network segment within this large network. Very beautifully planned. That is. In the early stage. I divided multiple subnets based on this large network. And announced this big network to the outside world. This involves the initial planning. If the previous planning is not done well. Like I just said. Here is a 4.0 network segment. Another 21-bit route is advertised to the outside world. Then it will cover some network segments. That do not exist. For example. 5, 6, 7. Due to the previous configuration. Some of the problems that may result are. You must advertise 2 network segments. To the outside world. Or you've announced more. Or what you advertise. We'll cover some waste network segments. Or you will advertise one more configuration. When everyone first came into contact with CIDR, may find it useless. But when you learn the NP stage, you will come into contact with a certain routing technology. That is, routing knowledge. Then you will know why among some companies to make some corresponding announcements with the internet. At that time you will learn application scenarios. When you combine into the project scene, let's look at this technology. You won't think it's useless. It's just that we're in the NA stage now. Because NP is mentioned, I have to talk corresponding to the two technologies. But since everyone is now, I really don't have a deep understanding of the project itself. So when you understand the problem, sometimes you can't see where the specific effect is. Feel a little contradictory. But I've made it as clear as possible to you. Now I will answer your questions. Is CIDR only used in egress gateways or firewalls? No. Generally speaking, as long as we want to make announcements to the outside world, CIDR will be used. For a company's internal, CIDR also has usage scenarios, but relatively large. It doesn't have an area that it has to function. As long as your routing table is relatively large, CIDR can be used. It just gives you a scene. Is an export docking operator that is connected to the internet, but not just on this device. When there are many routing tables in the enterprise, we will also use CIDR. It's just the best scene, because people still don't understand. How big should our network be? For example, what protocol is running? What is the final configuration? The size of the routing table? What kind of entry to achieve? Or how much? If I do aggregate again, for which traffic to aggregate? Which traffic can be given up? Which traffic must be precise? These people still don't understand. So when drawing, won't draw all the scenes. This is just one of the scenarios. Okay. We'll stop here. Then we also hope that students can follow us. We are ThinkMo Education. I'm Grolin Annesley from ThinkMo. I hope today's content is helpful to you. See you next class. Bye classmates.